9.58 seconds. 17 years ago, Usain Bolt ran the 100 meters in 9.58 seconds. Nobody has come close since. Here's the deal. I'm going to break down the physics that puts a hard ceiling on human speed, and I'll tell you exactly how fast a human could ever theoretically run the 100 meters. Stick with me. The payoff at the end is great. First, look at the world record over the last century. In 1912 it was 10.6 seconds. By 1968, 9.95. By 1999, 9.79. Bolt smashed it to 9.58 in 2009. That's almost a full second dropped in 100 years, and then the line goes flat. Today's athletes are bigger, stronger, better fueled, with carbon-plated shoes and faster tracks. The record hasn't moved. That's not bad luck, that's a ceiling. A 100-meter race has 3 phases. 0 to 30 meters is pure acceleration. 30 to 60 is top speed. 60 to 100, every elite sprinter is already decelerating. The race isn't won by who accelerates fastest, it's won by who hits the highest peak speed and who slows down the least. At his fastest, around the 65-meter mark, Bolt was moving at 12.27 meters per second, that's 44 kilometers per hour, on foot. And here's a number you won't see anywhere else. Going from 0 to 12.27 meters per second in roughly 5 seconds means his average acceleration was about 2.5 meters per second squared. For 5 seconds, Bolt out-accelerates about half the cars on the road. So what stops a human going faster? Not leg strength. Powerlifters can produce far more force than any sprinter, and they're slow on a track. The bottleneck is something else entirely. At top speed, an elite sprinter's foot touches the ground for just 0.08 seconds, 80 milliseconds, less than a blink. In that window, the foot has to push down to support body weight, push backward to drive the body forward, and lift off for the next step. The faster you run, the less time your foot has on the ground, so the force has to go up. Peter Wyand at SMU showed the real limit isn't how strong our legs are, it's how fast our muscle fibers can fire force into the ground. And remember, Bolt's reaction time in Berlin was 0.1 for 6 seconds. Anything below 0.1 is ruled a false start. His actual running across the 100 meters took only about 9.3 seconds. Speed comes from 2 numbers. Stride length, how far you travel in one stride, and stride frequency, how many strides you take per second. Multiply them and you get velocity. Bolt's numbers at peak, stride length about 2.85 meters, stride frequency about 4.3 per second. 2.85 times 4.3 is roughly 12.3 meters per second, the physics checks out. Now here is where it gets brutal. During those 80 milliseconds on the ground, his leg has to handle a force of roughly 5 times body weight, around 4,600 newtons. Newton's third law, the leg pushes 4,600 newtons into the track, and the track pushes 4,600 newtons back. That's what launches him forward. Multiply that force by his foot's velocity, 12.27 meters per second, and the peak mechanical power going through one leg during contact is about 56 kilowatts, comparable to a small car engine, generated by one leg for 80 milliseconds. And much of it isn't muscle. The Achilles tendon stores 35 to 50% of stride energy as elastic recoil, like a spring. Take that tendon spring away and human sprint speed drops by about 10%. Ostriches have an Achilles roughly 6 times ours, that's why they hit 70 kilometers per hour. So if you want to run faster than Bolt, there are only 3 doors, and all 3 are locked. Longer stride, limited by leg length. Bolt is 6'5" already, a sprinting outlier. Faster cadence, needs ground contact below 0.08 seconds, and muscle fibers can't twitch faster. More force per step, the skeleton is already near failure. More force means more injuries. Biomechanical models that combine maximum force, stride length, and stride frequency put the theoretical fastest 100-meter time somewhere around 9.0 to 9.2 seconds. Not 8. Not 7. Definitely not 5. Even with a perfect tailwind of plus 2 meters per second, the legal maximum, Bolt's 9.58 would have dropped only about a tenth, to roughly 9.48. He's already within 5% of the absolute ceiling of the human body. And compared to animals, we are not fast. A racehorse runs 100 meters in about 5.5 seconds. A cheetah in 5.95. A pronghorn in 6.0. An ostrich in 6.5. Almost every fast animal on Earth would humiliate Bolt. Long legs, upright torso, too few fast twitch fibers. We have the wrong body plan for sprinting. But we have the right body plan for something else. Endurance. We cool by sweating while animals cool by panting, which limits how long they can run. Over 30 kilometers a trained human will outlast a horse. Persistence hunting is real. Early humans chased animals until those animals collapsed from heat. We didn't evolve to outsprint. We evolved to outlast. So when you watch Bolt's 9.58, you're not watching a record. You're watching the human body pressed against its own ceiling. The record has been frozen for 17 years because biology won't let it move much further. 5 seconds is impossible. 7 seconds is impossible. Even 8.5 is essentially impossible. But that's the consolation, we were never built for the sprint. We were built for the race that crosses continents. If this changed how you watch a sprint, subscribe to Mathrix Labs. I break down the math hiding inside everyday things. Tell me in the comments, which world record do you think is closest to its physical limit? See you in the next one.